All right. This is unit 5 notes 4, so 5.4 notes. This is on predicting products. So before you move on to this, you want to make sure that you already are feeling pretty comfortable and have already been working on um, the chemical equations notes, the balancing chemical equations notes, and then the 5 types of chemical reactions notes. At this point, you should already be able to do in your unit packet pages 1 through 1, 2, and 3. So these should all be pretty good for you. We're going to learn the last major thing that you need to know, which will get you through unit pages 4 and 5 of your packet. So we're going to talk about predicting products. Okay, predicting products is a little bit more challenging. It's kind of a lot of fun, but it's a multi-step process. And there's not as many hard and fast rules. You just kind of get a handle for it. So what will happen is in a problem, I will give you, or the problem will give you the reactants, and you have to determine what the products are. It's exactly what it sounds like. So here's my example that we're going to be working with today. So we have copper 2 chloride and we have hydrogen sulfide. And this is going to be some sort of reaction. So just looking at this, we know that our products are going to be different than our reactants. So it's not just going to be copper chloride and hydrogen sulfide. Even if you switch them around, it's just like addition. It doesn't matter what order. 1 plus 2, is equal to 2 plus 1. It's the same thing. But in this case, yeah, we want something to happen. We want some sort of change, some sort of chemical change to happen. So the first thing that we need to do is identify the type of reaction. So if we go back to our 5 types, we need to figure out which type we think this is. Just taking a look at my kind of options here, it really looks to me like this is going to be double displacement. We have 2 ionic compounds and they trade anions and cations. They trade those positive and negative ions. So A, B, and C, D. In this case, A is copper, B is chlorine, C is hydrogen, and D is sulfur. So we have now identified this, step 1. This is a double displacement reaction. So now we have to figure out how things are going to switch around. So sometimes there's a lot of different ways to do this. It just kind of depends on how you conceptualize it. What I kind of like to do is write out the ions. So that's copper 2 plus, and there's chlorine minus. So I'm kind of separating them out and I'm ignoring all the subscripts because I don't really care about that. That's going to get switched around later. So this is one of the compounds. And the other compound is hydrogen and sulfur 2 minus. So we kind of have this scenario, this situation here, and this situation here. These are our 2 compounds, just splitting them off, kind of undoing the process of writing an ionic compound. So what it seems like to me here is that we're going to need to switch. The 2 positives are going to be the things that need to switch, or the 2 negatives. You don't want to do both because it'll be like switching back and forth. So I'm thinking about this like I'm going to take off my left shoe, and my friend is also going to take off their left shoe, and we're going to switch left shoes. We can't, like, if I take off my right shoe and they give me their left shoe, I can't put my left shoe on the right foot. It's the same idea. Positives have to exchange with positives, and negatives have to exchange with negatives. So what I'm going to do is I'm going to have copper and hydrogen switch places. And if I do that, in my new scenario, once copper and hydrogen have switched places, then copper is going to be with the sulfur, and hydrogen is going to be with the chlorine. When you do this, one of the rules is cation ions always come first. It's plus then minus. So you don't put the Cl first, you put the hydrogen first. So I'll make a little note of that. Cat ions before anion. So it's plus and then minus. So, think positively. Start with the positive one. That's a good way of thinking of it. Be positive before you're negative. Sure, why not? Say something nice before you criticize someone. Same idea. Okay, so we have determined which ions are going to switch, and now we know what the new products are going to be. The new products are going to be copper sulfide, and hydrogen chloride. So now we just need to write these new products, and we have to write them correctly. We have to neutralize them exactly the way we normally would. So it looks like actually these are already neutral for us. The copper has a 2+ and the sulfur has a 2-. That's going to be CuS. And we're also going to end up with HCl. Okay. So we've done that. Write out the new products. Great. The next step is balancing. So looking at this equation, this new equation we have here, it looks like it is not balanced. The copper is fine, but there's 2 chlorines here and only 1 chlorine here. So it can be very confusing, and a lot of students, when you're doing these, want to balance it as part of the writing formulas, but you don't actually do that. It's a completely separate step. It's the last step. Hydrogen chloride is HCl. We can't make it H2Cl2. We can't make it HCl2. We can't change copper or copper sulfide. It is what it is. But we can use the balancing, so the coefficients. So it looks like our hydrogen is also too much on the reactant side, not enough on the products. So I believe that should fix it. Okay, that looks pretty good. The very last step is to just figure out the state of matter for each species and put it in subscripts. This is not that important. I'm going to do it just for fun here. You would have to have some clues. We're going to learn more about this later, but I would say that these, it's probably going to be something like this. We'll learn more about this later, but I'm assuming that this is happening in an aqueous solution. Most reactions have to happen in water. So you put these things in water, you shake them up, and generally something is a solid and something is still dissolved in water. So don't worry about that yet, but that's just a good thing just to think about. Okay, so that is the general way that we do this. And now we can, let's go to the unit packet for a few more examples. But again, this is the basic process. Maybe in class, we'll even do another one together. We can take this last bit of notes then. But at least this gets you started. Every time you do this, it's kind of different, and it just kind of takes some time to get used to it. And once you get used to it, it's pretty great. So let me find unit packet. Okay, great. So if you look on page 4 of your unit packet, you are now able to do this. So these are the first couple of reactions. They've already given you what type it is. So that's really helpful. But later on, you're going to have to identify it. So it's taking that identifying skill to the next level. Not only do you only have the reactants, not the reactants and products. To help you, I'm drinking a soda. Well, it's not really a soda. It's I like to refer to these as hipster bubble water because they're really just like carbonated water with like a little bit of flavoring, and hipsters are into them. I don't know. I mean, I should talk. I am a hipster, but whatever, it's fine. Okay, so let's take a quick look at these. So one of these is a combustion reaction. So combustion is the best one ever to have to predict the products for. So let's take a quick look back at our notes at what a combustion reaction looks like. So a combustion reaction is any time you have a hydrocarbon and oxygen, which all of these follow that same rule. Here's what's cool. The products are always carbon dioxide and water, always, every single time. So you don't ever have to you just have to kind of know that, but if you know it, it's really easy. So we have now predicted the products. We identified the type of reaction. It was already told to us, but we could figure it out ourselves. We figured out what the products were. In this case, we don't have to worry about ion switching because it's always carbon dioxide and water. Next step is we need to balance this. So let's see, if I'm not mistaken, I think this is going to be a pretty easy one. We'll put a 6 here to balance the carbons. This is kind of how I do it. I'm pretty quick at this point in my life. I'll need a 6 here to balance the hydrogens. Yep, that looks pretty good. And then oxygens, let's see, we've got 2 times 6 is 12, 6 times 1 is 6, so it's 18, so it's just gonna be 9 here, and we'll just leave a 1. Okay, so that is an example of combustion. I think let's try number 1 and number 5 together over here. So the first one is a synthesis reaction. So what we know about synthesis reactions is that 2 different elements come together to form one compound. So we've got magnesium and we have iodine. So we know that whatever compound we form, it's going to be magnesium and iodine. So maybe right off to the side here, we're going to need to see, well, if magnesium and iodine become an ionic compound, this is the ions that they'll form. So we have to figure out, okay, it looks like the product is going to be MgI2 if we're going to neutralize out this compound. Okay. So basically it's what happens if, now remember I2, why is it an I2? It's a Hofbrinkel. Why is Mg not 2? It's not a Hofbrinkel, it's a Notbrinkel. So these are elements combining together to form magnesium iodide. Okay. Oh, you know what? I forgot to do states of matter. I'm going to go back and do that for you real quick, just for fun. C6H12 is a type, it's like hexane. So it's actually something that's in gasoline. You would not know this, but I know that it's a liquid. So I'm going to put L for liquid. Oxygen is a gas because it's in the air. We breathe it all the time. And then we know that carbon dioxide and water, carbon dioxide is definitely a gas. Water may or may not be. I'm going to say it's a gas in this case because it's probably very hot and it becomes water vapor. It could be a liquid though. Could be either way. Also, if you burn stuff, like there's no like water that just goes pouring out. It actually just becomes steam. It's a vapor. So you might know that. Okay. As for these ones, these are actually both solids because they're elements, and then an ionic compound is always a solid too anyway. We're going to talk more about that in the next set of notes, so don't worry about it for now. I'm just throwing it in there just for fun, but just focus in on the balance, the products part. Okay, let's try single replacement. So single replacement or single displacement. This is one where we have two possible scenarios. We know that the element zinc is going to replace either the hydrogen or chlorine, and it's going to boot one of them out. So we started off with one compound and an element, and we're going to end up with one compound and an element. So let's just think about this for a second. Over here, we've got H plus and Cl minus, if we want to kind of break it down. And we know that if zinc is going to become an ion, it's actually going to become a +2. So someone actually should have put a little parentheses in there for 2. Oops, sorry. Okay, so what's going to happen here then is the hydrogen and the zinc are going to have to switch places because they are the two positives. So the zinc is going to end up with the chlorine and the hydrogen is going to end up by itself. So let's think about this off here to the side for a second. So we've got zinc 2+ and chlorine is 1-. So the compound it's going to form is going to have to be ZnCl2. And then we're going to have hydrogen doesn't have anything to pair off with, so it's just going to be by itself. So it's going to be hydrogen. Wait a second, did you catch something? I did something wrong. Hofbrinkel, if hydrogen is an element by itself, it has to be H2. All right, so with this in mind, the next step is balancing, and I think if we just put a 2 here, we're good to go. Awesome. Okay, these are going to take a little while for you to learn. You have pages 4 and 5. Oops, my lights went out. 1 second. You guys know this happens in my classroom. If I sit at my desk, the lights go out. Okay. You've got 2 pages to practice on, pages 4 and 5. And the next couple of pages, we're going to go into solubility. That'll be the next notes. But yeah, this stuff will come up. So you've got lots of places to practice. Currently, this doesn't have stuff written on it, but I'm going to finish this up, and this will be an answer key very soon. Now, we are going to, this is the kind of thing that I want to use those tutoring hours for. Excuse me, but I do have a couple of other resources you can use. If you guys want to go to my playlist on YouTube, this video right here, predicting the products of chemical reactions, it's 20 minutes or 18, almost 19 minutes, is going to be more examples. I really like the organic chemistry tutor. He does like, all of his stuff looks like Khan Academy, but I like him better than Khan Academy for chemistry, actually. Unfortunately, Tyler DeWitt does not have videos on this, or neither does Bozeman Science or anyone else. But these are pretty good. So I will leave you there to work on those. Keep practicing these. It's going to take some time, but you will eventually get it. It's just kind of like a puzzle that you have to figure out. It's got lots of steps, but it's quite fun. And I'll see you all in the next video for the last bit of notes. We're almost done.